Okay, so good evening, everyone, once again. And I hope my screen is visible to you, my voice is clear for you. And by considering that, we are going to start our third chapter today because I think we are done with our previous two chapters, right? So, this is the new chapter that we are going to start today. And I can see very few students have joined. I don't know about others. So, I just put a message on the group and maybe we can wait for one more minute. Right. Okay. So people are joining, but quite late. Students, I would request everyone to join at least 2 minutes before the scheduled start of time. Right. So you need to join at maybe 6:58 or 6:55. That would be helpful. Okay. Just wait for one more minute. Okay, fine. So I think this is enough wait, and we should not waste much more time for those who are not willing to join on time. Okay. So, students, our third chapter is understanding quadrilaterals. Okay, so you may have some background about this chapter or this topic particularly. You might have learned about few of the quadrilaterals in the last standard, that is in the seventh standard, right? So we're just going to take some revision kind of thing or a refresher for the things that you have learned in the seventh standard, right? So you know that a paper is a model for plane surface. So when you join a number of points without lifting a pencil from the paper and without retracing any portion of the drawing other than single points, then you get a plane curve. Okay, so this is the simple definition of a plane curve. And try to recall different varieties of curves that you have seen in the earlier classes and match the following. So caution is there given there that a figure may match to more than one type. It is not like there are four figures and four types. So a figure may relate to more than one types, right? So we'll go with the types and then we can go with the figures. So can you tell me which of them are simple closed curves? So you need to put your answers in the chat box. Which of them are simple closed curves? I hope my voice is pretty clear. If there's any issue with my voice, you can let me know. Okay. Okay, I can see every one of you have put their attendance. Okay, 3 and 4 are simple closed curves. What about others? Do you have any other answer? किसी के पास कोई और आंसर है? 3, 2. Okay, simple closed curve. 2, 3. Okay, we're not talking about plain curves. Okay, simple closed curves. I don't think 2 is a simple curve. It is closed curve. It is not closed curve. There are two open ends, right? So maybe 3 and 4 is the correct answer, right? 3 and 4 are the simple closed curves. Now we'll go to the B type, a closed curve that is not simple. 2, yeah, okay. Third one, simple curve that is not closed. Simple curve that is not closed. So it is quite obvious, the first one, and not a simple curve. Not a simple curve. Is it 2? Is it one? I guess both of them, right? Okay, so that was the recall thing for the last standard, right? So next topic we have is polygons. If simple closed curve made up of only line segments is called a polygon. So these curves are the polygons, and these curves are not polygons. You are very familiar with what is polygon and what is not, right? So we don't need to focus more on this. So try to give few more examples and non-examples for a polygon. Draw a rough figure of a polygon and identify its sides and vertices. So simply we can take examples of these polygons itself, right? And we can identify their sides and vertices as well. So see, these are the sides, right? And these are the vertices of these polygons, right? Now, classification of polygon. So let us suppose now we classify polygons according to the number of sides or vertices they have. Okay, so now for triangle, how many vertices and how many sides we have? It's pretty clear that it has three vertices and three sides. Triangle has three sides and three vertices. That's why it is called triangle. Quadrilateral, yeah, obviously two, three, three. For quadrilateral, there are four vertices and four sides. For pentagon, it is 5, 5. For hexagon, it is 6, 6. And for heptagon, it is 7, 7. Octagon, 8, 8. Nonagon, it's 9, 9. And decagon, it's 10, 10. Right? So for a polygon with n vertices, will have n sides. Right? So this is the conclusion that we can take. Now, next topic is diagonals. So what are diagonals? A diagonal is a line segment that connecting two non-consecutive vertices of a polygon. So see, this is important. Non-consecutive vertices. If a line or yeah, if a line segment connects two non-consecutive vertices of a polygon, then that line is said to be a diagonal. Okay, so in this figure, particular PQRS, this is a rectangle, and in this rectangle, we can see PR and SQ are the uh, diagonals, right? So if you see this pentagon, you can see there are DA, AC, EB, EC, and DB. There are many. Actually, there are one, two, three, four, right? Four diagonals, I guess. Yeah. Or how many? Four or five? Five diagonals, right? Now, if you see this, this is not a triangle, students. This is again a polygon, right? This is a polygon, or this can be considered as quadrilateral also. So K KLMN. This is a polygon or quadrilateral, and it has two diagonals. So the diagonal is KM and LN. So these are two diagonals. So we have to answer few of the questions here. So PQ is a diagonal. And what about LN? So if you see PQ, it is not a diagonal because it is connecting two consecutive points. So that is not that does not comes under definition of polygon. Sorry, quadrilateral diagonal. So PQ is not a diagonal. And what about the next one? LN. LN is a diagonal. LN is a diagonal, right? But again, we have to consider whether these are anterior or exterior diagonals. See, what is means by interior? If it comes inside the closed curve, so then that is said to be interior. And if it is outside the closed area, so that is said to be exterior. So for in this case, if you see which of the if you know observe these three figures, आप अगर इन तीन फिगर्स को देखते हो, so इसमें से मुझे बताओ कि which diagonal is the is in exterior area, or in is it external diagonal? Which one? And name the diagonal. Name the diagonal. It has some name. Somebody has given it as well. Yeah, LN. LN is the diagonal which is in exterior. Right. Okay. I hope you get it, everyone. Okay, now let's move to the next topic, that is
convex and concave polygon. So now we know that what is interior and exterior diagonal. So we can figure out whether the given polygon is convex polygon or concave polygon. How can we do that? Now, if you see few of the examples here, these are convex polygons and these are concave polygons. Okay, so how do we figure it out? So can you find how these type of polygons differ from one another? So polygons that are convex have no portions of their diagonal in their exteriors. See, convex polygons have no portion of their diagonals in the exteriors or any line segment joining any two points, different points in the interior of the polygon lies wholly in it interior of it. Is this true for concave polygons? So don't get confused. Simply, if you see these convex polygons, uh, you draw a diagonal. Okay, so this is a diagonal. Again, this is a diagonal, but these all are in the interior of this figure, right? But if you draw polygons for this, so if I draw polygon, sorry, diagonal for this, so this is coming in exterior. Again, this is coming in exterior. This diagonal will be outside the our figure, right? So these are which polygons? These are concave polygons, right? So this is how we can differentiate convex polygons and concave polygons. Now, regular and irregular polygons. So I don't know whether I'm going too fast or not, but I'm considering that it is pretty easy topics, and that's why I'm running it a little fast. Okay, so are you able to understand, students, whatever we have learned till now? Do you have any doubts? Yes. Okay. Anyone with any doubt? Okay. Thanks for confirming that you don't have any doubt. All right. Okay. Thank you so much for confirming, students. Okay, so we can proceed with the next topic. So that is regular and irregular polygons. A regular polygon is both equiangular and equilateral. So for example, a square has sides of equal length and angles of equal measure. So hence it is a regular polygon. It's pretty simple. If the angles and the sides are equal, then that polygon will be said as regular polygon. And if even one of the side or one of the angle is not equal to others, then that will not be a regular polygon. It will be classified as an irregular polygon, right? So you can see some examples of regular polygons over here, and here are the examples of some polygons that are not regular. Okay, so in the previous classes, you have come across any equilateral, any quadrilateral that is equilateral but not equiangular. Recall the quadrilateral types you saw in the earlier classes: rectangle, square, rhombus, etc. Is there triangle that is equilateral but not equiangular? So if you see a rhombus, okay, so rhombus may have um, all of the sides equal, right? But it will have a pair of angles. That means two angles will be equal and two angles will have some other value, but again those will be equal. So this will be again classified as not regular or non-regular, irregular polygon, right? Yeah. So the next topic that we want to study is angle sum property. So do you remember angle sum property of triangle? Obviously, you must be remembering, right? So the sum of measures of three angles of a triangle is 180 degree. So recall the methods by which we try to visualize this fact. Now we extend these ideas to quadrilateral. So every one of you knows what is sum of angles of a triangle. It's 180 degree, right? But what if we have to find out sum of angles of any quadrilateral, okay, or any maybe polygon? So we Yeah, it's 360, right? So what about polygons? So we can figure that out. So if you see the first example given here, it is a quadrilateral, say ABCD. See, this is ABCD, this is a quadrilateral, and we are dividing it into two triangles. How we are dividing it? By simply putting a line here, AC. So there are two triangles here, ABC. One is one of the triangle, and ACD is the other triangle. So there are two triangles we have, right? And as we know, sum of angles of any triangle is 180 degree, right? So angles in this triangle are going to be 180 degree, and similarly 180 degree will be here also, right? So 180 plus 180, we can consider it as 360, or it is 360. Yeah, and Shlok has also written the formula as well, how to find the sum of angles of polygons, right? And that we are going to learn in this chapter ahead as well. Yeah, so here's some simple exercise that we want to perform. So uh, okay, so these are the figures and we have to classify them on the basis of the following. So can you just tell me which of them are simple curves? अभी यहाँ पे जो figures दिख रहे हैं 1 से लेके 8 तक, so इन figures में कौन से जो curves है, they are simple curves. So can you just put their number like 1, 2, 3, 4, whatever the number is. So for simple curves, I want your answers. Okay, yeah, 3 is simple curve. I don't think so. Okay, so the answer for first one is 1, 2, 5, 6, and 7. Okay, this is simple curve, this is simple curve, this is simple curve, this is simple curve, and this is simple curve. Okay, so this is the correct answer. 1, 2, 5, 6, and 7. Now tell me about simple closed curves. Which of them are simple closed curves? Again, the answer is going to be same, right? 1, 2, 5, 6, 7. These are simple closed curves. Yeah. Now tell me which of them are polygons. Which of them are polygons? 1, 2, 4. Polygon is fourth one is polygon? I don't think so. It's a complex figure. It's not a straightforward polygon, right? So 1 and 2 will be the correct answer, students. Only two polygons are there. That is 1 and 2. Okay. Now the fourth one, convex polygons. So what is definition of convex polygons? Convex polygons have no part of their diagonal in the exterior. One, no. Convex, it's concave. First one is concave. Okay, first one is a concave polygon, and second one is a convex polygon. So second is the correct answer, convex. Second. 2 and 6, no. How can 6 be the polygon? 6 is not polygon itself, right? Yeah, 2 only. Okay, so how many diagonals does each of the following have? Now I want every one of you to take out your notebook and draw these figures. I'm just zooming in so that the question is clear for you. Okay, so how many diagonals does have does does each of the following have? Now a convex quadrilateral, you have to draw answer of E. Okay, answer of E is first one, no? Answer of E is first one. Concave polygon is first one. Yeah. Okay. So how many diagonals does each of the following have? So you draw a convex quadrilateral and tell me how many diagonals they have. Two. Okay. So you need to draw a regular hexagon and tell me how many diagonals it have. How many diagonals it will have? It will have nine diagonals, right? A regular hexagon will have nine diagonal students. If you're not very sure, you can just draw it and try to draw all the diagonals and count them. So it will be nine. How many? Okay. How many diagonals a triangle will have? Third one. C. How many diagonals a triangle will have? Okay. Shlok has all three answers in one go. How many diagonals? Zero diagonals, right? Right, students? I can see only two students are answering, or three maybe. Yeah. Mishra, Aidur Rahman, and Shlok. These are the students that are answering. I want others. Okay, yeah, okay, yeah. So zero diagonals a triangle will have. Now, the next question: what is the sum of measures of the angles of convex quadrilateral? Will this property hold if the quadrilateral is not convex? Make a non-convex quadrilateral and try. So we know that sum of measures of angle of a quadrilateral convex, it will have what will be the sum, students? It will be 360-degree. Okay, so first try to draw a convex quadrilateral. Now for our convenience, what I will do is I will take this quadrilateral only. This is a convex quadrilateral, right? So if you measure as the angles, so I have divided it into two triangles, so it will have 180 plus 180. That means 360 as the sum of measures of the angles for convex quadrilateral. Now I need to draw a concave quadrilateral. Okay, so my first question is it possible to draw concave quadrilateral? My first question is that. After that, we will could draw it if it is possible. Yeah, it is possible to draw a concave quadrilateral that we have already seen, students. Correct. Yeah. So for now, I will take this is the concave quadrilateral. We can say, is it? Or it's not. It's not a quadrilateral. It has more than four sides, right? So let's take example of let us say this one. Can we take this one? This is a concave quadrilateral, right? Yeah. So if we try to measure angles of this quadrilateral, so what will be its sum of interior angles, I would say, right? So if I divide this quadrilateral in two, so again I will be having two triangles. This is the first triangle and this is the second triangle. So it will have 180-degree as a sum of angles, and the second triangle will also have 180-degree as a sum of angles, and combinedly they will again have 360 as their sum of angles. So the same property is applicable for convex as well as concave quadrilaterals. So this is how we have proved it. ठीक है बराबर. Okay, so one more thing, students. I just want to confirm with you. I Yeah, this property hold if the quadrilateral is non-convex. Yeah, yeah. So that's the explanation. All right. So one more thing I want to ask all of you, that most of the times I'm speaking in English only. So if you want me to elaborate in Hindi as well, I'm comfortable in that as well. So please confirm that I'm going okay, or do I need to use a Hindi bit more? मुझे हिंदी में भी ज़्यादा बात करना चाहिए, या फिर आप सब लोग कंफर्टेबल हो विद दिस? ओके, All right, so I will continue what I'm doing. Right. Okay. Thanks for your quick confirmation. All right. Let's go to the fourth one. We have ex- we have question that is asking us to examine the table, and each figure is divided into triangles and the sum of angles deducted from them. Now, as Shlok has already given us the formula, that is the same formula is going to be applicable here, but we are going to go through it thoroughly so that it fits in your mind, right? So now we have to find out the sum of angles of any polygon. Okay, not quadrilateral, I would say polygon. So if you we all know that the sum of angles of a triangle is 180 degree, and I think we have proven this as well in seventh standard, right? There were proofs as to why the sum of angles of triangle is 180 degree. We have proven this, right? So next we have is a quadrilateral, and we are going to find out some of their angles now. So if you see, the formula we are populating is 2 into 180 degree. That means there are two triangles. We are considering them as two triangles, and two triangles have 180 degree as some of their angles. So that was two. So that's why 2 into 180 is the sum of angles of this triangle and quadrilateral. And we are again splitting this 2 as, or we are just converting this 2 as 4 minus 2. Okay, just as to formulate the formula. So a is equals to 900, b is equals to, yeah, okay, you're giving the answer for the next questions maybe. All right, so in this figure, in this polygon, if you see, there are three triangles, one, two, and three triangles, right? So for three triangles, we have 3 into 180, and 3 can be again written as 5 minus 2, 5 minus 2 into 180. So this will give us sum of all the angles in this polygon. Similarly, for a figure which have six sides, right? 1, 2, 3, 4, 5, and 6. Six sides are there. So, and we are dividing it into four triangles, 1, 2, 3, 4. So 4 into 180, again we have formula 6 minus 2 into 180, so that we can say कि we have got a formula, right? हमें एक formula मिल चुका है. What is the formula? Number of sides minus 2, right? Number of sides minus 2 into 180. So this is the formula that Shlok has already given us, and we have that here as well. So what can you say about the angle of sum of convex polygon with number of sides 7, 8, 10, and n? So although Shlok has already written answers for them, but I want you to calculate them. Okay, so Aidur Rahman has written the calculation as well. That's pretty impressive. Yeah. So 7. So for first one, what we will do, we will apply the formula 7 minus 2 into 180. Right, so it will be 5 into 180, that is equals to 900. For second one, we will apply the formula 8 minus 2 into 180, that is 6 into 180, which will be 1080. So this is how we can formulate a formula. So what is a regular polygon? State the names of the regular polygons of three sides. So what is a regular polygon with three sides? Can you answer it? It will be a triangle, obviously. If it has three triangles, it will be a triangle, but not necessarily all the triangles are regular polygons, are they? What is definition of regular polygon? The definition of regular polygon says, if a polygon is having all the angles and all the sides equal, then it will be considered as a regular polygon, right? So for triangle, so if you take example of this triangle, no, sorry, this there is no triangle. Let us take example of this triangle. So is this a regular polygon? It's not. You must be remembering concept of equilateral triangle. Yeah, a polygon with equiangular and equilateral. Yeah. So do you remember equilateral triangle? So it has all its sides and all its angles equal, right? And what are the angles? Can you tell me what will be the angle for this kind of, yeah, equilateral triangle? And what will be the angle for these kind of triangles? 60 degree. Perfect. It will be 60 degree, right? Yeah. So let's take the second one. A regular polygon with four sides. Which one can be? Okay, square. It can be square. Can be rhombus. Rhombus is regular polygon, right? No? Okay. What about others? Yeah. Square or a quadrilateral. Yeah, because it's not equiangular. Rhombus is not equiangular. So square is the perfect example of regular polygon. A polygon, a regular polygon with six sides will be called, you've already seen this, hexagon. Yeah, hexagon. Yeah, perfect. All right. So now in the sixth example, we have to find the angle measure x in the following figures. So this is pretty simple. Now we know that this is a polygon with four sides and it will have some of their angles as 360 degree. So we can easily find out the value of x. How can we find out? X plus 50 plus 130 plus 120 is equals to 360. We can, right? So now if you add 50 plus 130 plus 120, so 120 plus 130 is 250, 250 plus 50 is 300, and if you subtract 300 from 360, so x is going to be equal to 60. I hope this is not confusing for any one of you, right? It's pretty simple for everyone. Okay, so the value of x is 60 for the first figure. Now let's go to the second figure. So in this second figure, what can be the value of x, or can you just write the formula to find the value of x? How can we find the formula of x? How can we find the value of x? Can anyone write the formula without writing the actual answer or the equation that we are going to use? I don't need direct answers. I need how you are getting there. Okay, 90 plus 70 plus 60 plus x is equal to 360, or 360 minus 70 plus 60 plus 90 is equals to x. Okay, so either you have written the formula right correctly, but it will be it will be correct if you add a bracket for 70 plus 60 plus 30, because you're just subtracting 70 from 360 and adding 60 and 90, which is not correct. Okay, all three should be subtracted from 360, right? You either write this like 360 minus 70 minus 60 minus 90, or you can write as I'm sorry if I'm pronouncing your name incorrectly, but the Sneha has written it incorrectly, right? So this does matter, okay? How you write it. It is not necessary to write your answers quickly. It is necessary to uh, write your answers in a proper way, okay, or in a correct way. Yeah. So don't be in a hurry. If you are taking, yeah, now you got it correct. Yeah. Okay. So take your time, but make sure you are typing it correctly. Yeah, so now it's pretty clear for everyone. So you have written the formula, you have identified that if this angle is a 90-degree angle, obviously the opposite angle is also going to be 90 degrees. So this angle we consider it as 90 degree. So 90 plus 60 plus 70 plus x is equals to 360. right? So we can easily find out value of x. Okay, now we have to find the value of x here. Okay, so how we are gonna do this? See, this angle is 70 degree, this is 60 degree. Now this total angle is 180 degree, right? And this total angle is 180 degree. So 180 minus 70. So this angle is going to be 110, right? 110. And this angle is going to be 120. Okay. So this is 110. This is 120. So this is 110. This is 120. Okay. And this is 30 degree. So I have written three angles. Now if you see, this is a figure with five sides: one, two, three, four, and five, right? So what is the sum of polygon with five sides? Tell me, what is sum of polygon with five sides? Is it 360? No, it's not 360. Sum of polygon with five sides. It is 540, right? Everyone? Yeah, it's 540. So now what you have to do is you have to write it like 110 plus 120 plus 30 plus 2x is 540, and then you have to find out the value of x, right? 110 plus 120 plus 30 plus 2x is equals to 540. So x equals to 140. Somebody has found it. So I will write for your convenience if you're not getting it, right? 110 plus 120 plus 30 plus 2x. See, this both angles are same, right? So that's why we write it to 2x is equals to 540, right? So if you use this formula, if you solve this, is it 130? Or which one 130? I think it is 120 only, na? 60 plus. No, no, no. You're getting your answer. No, it's okay. It's okay. It's okay. I get that. It happens sometime. Don't worry. Okay. But it is 120. Yeah. No problem. No problem. But just be active in the class. Okay. That's okay. Mistakes happen. All right. So this is the formula that we are going to use to find out the angles. So x is equals to 140 will be the correct answer. I hope everyone has got it, right? So if yes, so can I get yes from everyone in the chat box quickly? Yeah, one, two, three. Okay. What about others? Are you there with me? Yeah, fine. So for this one, for the last figure that is here, how can we find it out? So again, this is the polygon one, two, three, four, five. Five sides are there, and this is a regular polygon, we can say, right? So that means every angle is equal. So x is equal to 540 by 5. That is x is equals to how much? Calculate it. 108, 108. Yeah. So every angle will have measure of 108 degree. So this is how we solve the examples. Yeah. Now, for today, we are going to take these two examples and we will wrap up for today. Okay. So in the first figure, we have to find x plus y plus z. So for that, we need to calculate the value of x, y, and z individually, and then we can uh, find their sum. It's pretty easy, right? So what is the value of x, student? What is value of x? It's pretty clear. There is no need of calculation at all. What is x? Value of x is 90. Yeah. So just keep it as x is equals to 90. Okay. So can we find the value of z? Can we find the value of z? What it is going to be? It is going to be 150. Z is going to be 150, right? Yeah. And then now we have x, we have z, we need to have y. So for y, we need to have measure of this interior angle. So what is measure of this interior angle? So as we know, sum of angles of a triangle is 180 degree. So 90 plus 30 is 120. And to make it 180, we need 60 more. So that means the interior angle is 60 degree. And if it is 60 degree, then the angle outside, that is y, is 120. Okay. So x is 90, y is 120, and z is, yeah, uh, okay, so and z is what, 150. So calculate it, how much? 90 plus 120 plus 150, so it is going to be how much? 300. Only 300. 360. Yeah, perfect. So it is 360. Okay, so the last figure for today. Now we want to find out value of each of the angle given. Value of x is going to be 60. Pretty simple, you all know it. Value of y is going to be 100 maybe, right? Then value of z is going to be 120. What is value of w, students? What is value of w? How can you calculate that? So for this particular angle, or for this particular polygon with four sides, we can use the formula that all sum of all the angles will be how much? 360, right? So 120 plus 80 is 200. 200 plus 60 is how much? 260. 260. Now if these three angles are 260 degree, so the third one should be 100 degree. So if this third one is 100 degree, then the w that we need is 80 degree. Fine. So write the formula: 80 plus 60 plus 100 plus 120. What it is going to be? Uh, uh, it's not 260. It's going to be more than that. Yeah, it's 360. 80 plus 60 plus 100 plus 120, that is 360. Yeah, now you got it. Okay, no worries if you miscalculate. All right, so we are done with the problem set, this problem set, and when we start our next class, we will be starting with the fresh topic, that is sum of measures of exterior angles of polygon. Actually, we've got some hint of that, but we are going to learn it in a more detailed manner, right? So that's it for today, students. I hope whatever I have told you, you understood that. And yeah, thank you so much for joining. I will see you next week, right? Till then, take care and bye bye. You are free to leave the class for today, and the class has ended. Bye bye, students.